Actually, good morning. Finally, back on the screen. ಇದೊಂಥರ ಬೆಳ್ಳಿ ಪರದೆ ಇದ್ದಂಗೆ ನನ್ನ ಪಾಲಿಗೆ. ತುಂಬ ಅಡೆತಡೆಗಳು ಬಂದಿತ್ತು. ಅಡೆತಡೆಗಳು ತುಂಬಾ ಬಂತು. ಇನ್ ದ ಮೀನ್ ವೈಲ್ ನಾನು ಒಂದು ಕೋರ್ಸಲ್ಲಿ ಬ್ಯುಸಿ ಆದೆ. ಒಂದು ರೆಕಗ್ನೈಸ್ಡ್ ಯೂನಿವರ್ಸಿಟಿಯಿಂದ ಒಂದು ಕೋರ್ಸ್ ಮಾಡೋದಕ್ಕೆ ಹೋಗಿ ಬ್ಯುಸಿ ಆದೆ. ನಾನೇ ಯಾವಾಗಲೂ ನನ್ನೊಂದು ಡಿ ಪಿ ಇದೆ, ವಾಟ್ಸಪ್ಪಲ್ಲಿ, ಇನ್ಸ್ಟಾಗ್ರಾಮಲ್ಲಿದೆ. ದ ಕೀ ಟು ಸಕ್ಸಸ್ ಈಸ್ ಟು ಫೋಕಸ್ ಆನ್ ಗೋಲ್ಸ್ ನಾಟ್ ಆನ್ ಅಬ್ಸ್ಟಕಲ್ಸ್ ಅಂತ. ಏನೇ ಅಡೆತಡೆಗಳು ಬಂದರೂ ಅದ್ರ ಬಗ್ಗೆ ನಾವು ಅದನ್ನು ವಿ ಹ್ಯಾವ್ ಟು ಓವರ್ಕಮ್, ವಿ ನೀಡ್ ಟು ಓವರ್ಕಮ್, ವಿ ಶುಡ್ ಟ್ರೈ ಟು ಓವರ್ಕಮ್ ಫ್ರಮ್ ದೋಸ್ ಅಬ್ಸ್ಟಕಲ್ಸ್. ಈ ಸ್ಟಿಕ್ಕರು ಕಿತ್ತೋಗ್ತಾ ಇತ್ತು ಕೆಲವು ಈ ಸರಿ. ಯೂಸಿಂಗ್ ದ ಹ್ಯಾಮರ್ ಆ್ಯಂಡ್ ನೈಲ್ಸ್ ಬೈ ಅಪ್ಲೈಯಿಂಗ್ ಇಂಪಲ್ಸಿವ್ ಫೋರ್ಸಸ್ ಪ್ರಾಪರ್ಲಿ ಐ ಹ್ಯಾವ್ ಫಿಕ್ಸ್ಡ್ ಇಟ್ ದ ವಾಲ್. ಐ ಹೋಪ್ ಪ್ರಾಪರಾಗಿ ಫಿಕ್ಸ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀನಿ ವಾಲಿಗೆ. ಅಡೆತಡೆಗಳು ಬರೋದು ಬೇಡ ಈ ಸರಿ. ಎವ್ರಿ ಸ್ಯಾಟರ್ಡೇ ಆ್ಯಂಡ್ ಸಂಡೇ 2 classes, Saturday 1 class, definitely it will be there. I want to explore my talent, myself. I should improve. ಅದಕ್ಕೋಸ್ಕರ ಮಾಡ್ತಾ ಇಲ್ಲ, ಟ್ಯಾಲೆಂಟ್ನ ತೋರಿಸೋದಕ್ಕೋಸ್ಕರ. ನನಗೆ ದೇವರು ಅಷ್ಟು ಟ್ಯಾಲೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಂದ್ಕೊತೀನಿ. ದಟ್ ಟ್ಯಾಲೆಂಟ್ ಶುಡ್ ಎಕ್ಸ್ಪ್ಲೋರ್ ಟು ದ ವರ್ಲ್ಡ್. ನನ್ನ ಕ್ಲಾಸು ಯಾವುದೋ ಒಂದು ತರಗತಿಗೆ, ಯಾವುದೋ ಒಂದು 4 ಗೋಡೆಗಳ ಮಧ್ಯಕ್ಕೆ ಸೀಮಿತ ಆಗಿರಬಾರ್ದು. 4 ಗೋಡೆಗಳ ಮಧ್ಯೆ ಸೀಮಿತ ಆಗಿರಬಾರ್ದು. ಸೊ ಟುಡೇ ಐ ವಿಲ್ ಟೀಚ್ 30 minutes or 40 minutes about this analogy between electrostatics and magnetostatics. This magnetostatics and electrostatics, the basis, the main building block of this electrostatics and magnetostatics, I will teach today. See, electrostatics magnetostatics, magnetostatics. ಇವತ್ತು ಕೂಡ ಒಂದು ಅಡೆತಡೆ ಬಂದಿದೆ. ಈ ರೆಡ್ಡಿಂಗು it is not writing properly. Unfortunately, here some shops are almost 1 kilometer. ಮತ್ತೆ ಹೋಗಿ ಬರೋದಕ್ಕಾಗಲ್ಲ. ಇರಲಿ, in the next class I will use one blue, black, red, 3 colors. ರೆಕಾರ್ಡ್ ಆಗ್ತೀನಿ ಹೆಂಗಪ್ಪ. It is recording. Okay. ಆ್ಯಕ್ಚುಲಿ ಒಂದು ಕ್ಲಾಸ್ ಲೈವ್ 40 minutes ಮ್ಯಾಕ್ಸಿಮಮ್. 40 minutes ಮೇಲೆ ರೆಕಾರ್ಡ್ ಮಾಡಿದ್ರೆ ಅದು ಅಪ್ಡೇಟ್ ಆಗೋಲ್ಲ, ಅದು ಅಪ್ಗ್ರೇಡ್ ಆಗಬೇಕು ಯೂಟ್ಯೂಬಲ್ಲಿ ಇರಲಿ. ಸೊ ವಿತಿನ್ 40 minutes, I hardly will take 40 minutes class only every Saturday and Sunday. What are the basis of this? What is the analogy? Analogy means similarity. What is the analogy? Analogy means similarity between this electrostatics and magnetostatics. Analogy. Check whether this red ink is working or not. It is not working. Leave it. Not working properly. See, this electrostatic mainly depends upon the Coulomb's law, whereas this magnetostatics depends upon the Biot-Savart's law or Laplace law. Coulomb's law. What is this Coulomb? Who is actually this fellow? This Coulomb is actually, it is one of the scientist name. Coulomb's law. Here Laplace law, 2 names are there. Laplace law or Biot-Savart's law. See, this Coulomb's law, it is actually one of the scientist's name. He is introduced the concept of charge. That's why he kept his name only for the SI unit of electric charge, Coulomb. SI unit of electric charge is Coulomb. So positive charge and negative charge, positive charge and negative charge together constructs dipole. System of positive and negative charges separated by some distance, separated by a small distance, or in electric dipole they will use distance 2a also they will use. Electric dipole means what? What is electric dipole? A system consisting of equal and opposite positive charges A system consists of equal and opposite point charges separated by a small distance, that is called as electric dipole. Separated by a small distance, that is electric dipole. This electric dipole acts like a bar magnet north and south pole. Positive charges almost behaves like a north pole, and this negative charge behaves like a south pole. Characteristics almost similar, just like, not exactly, almost. So when you come to the properties, I will explain some similarities, basic properties. What are the similarities before going to Coulomb's law and Biot-Savart's law? See, like charges, positive positive, and like poles, north north, same poles, or south poles, south south, they will repel each other. Positive and positive. Okay, I will write here positive and positive. Similarly, north and north. Similarly, south and south will repel. Whereas positive and negative, north and south poles will attract. Here, repel. Similarly, that's why in Coulomb's law they will use the electrostatic force of attraction and repulsion both. The statement, what is the statement of Coulomb's law? The electrostatic force of attraction and repulsion is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between those two charges. It is there like that. Understood? See, this bar magnet, this is the similarity. Like poles will repel, unlike poles will attract. Like charges will repel, unlike charges will attract. That is the similarity. When coming to the field lines, how it will be the pattern of field lines. See, electric field always diverges. Electric field always diverges or emerges out from a positive charge. Similarly, magnetic field lines. Here in electric dipole, electric field, we will deal with electric field. Here in magnet, bar magnet, we will deal with magnetic field. Here electric field lines, there magnetic field lines. Similarly, from north pole, the magnetic field lines will be like this. One of our teacher in the last class troubled to explain this. Is a mathematics teacher, but he is very good teacher, really. Very innocent. Tumba vayasagiದ್ರು ಕೂಡ he will respect each and every human being, and every student will teach equally. So that is the ಒಬ್ಬ ಶಿಕ್ಷಕನಿಗೆ ಇನ್ ಜನರಲಿ, ನಾಟ್ ಐ ಆಮ್ ಡೇಟಿಂಗ್, ಒಬ್ಬ ಶಿಕ್ಷಕನಿಗೆ ಇರಬೇಕಾದ ಗುಣ ಏನು ಅಂದರೆ ಎಲ್ಲರೂ ಒಂದೇ ಥರ ಟ್ರೀಟ್ ಮಾಡೋದು. ಓದಲೇ ಇರಲಿ. ಸೊ ಡು ನಾಟ್ ಅಂಡರ್ ಎಸ್ಟಿಮೇಟ್ ಆರ್ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್. ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮೀನ್ಸ್ ನಾಟ್ ಡಿ ಬೈ ಡಿ ಟಿ ಆರ್ ಡಿ ಬೈ ಡಿ ಎಕ್ಸ್. ಸೊ here north pole electric field lines, magnetic field lines, here electric field lines, here magnetic field lines always emerges or diverges out from the positive charge and north pole respectively, related to electric field and magnetic field, and related to electric field lines and magnetic field lines. Similarly from, I will write here, from negative charge and what south pole, whatever negative charge and south pole, you can like this only, you can write like this only, you can write. Okay, or you can take 3. See, negative charges converges or terminates at negative charge, converges or terminates ends at south pole. So arrow mark should be inwards here. Arrow mark should be inwards. The arrow mark should be inwards. In an electric dipole, what is the direction of electric field line from positive to negative. They will go like this, from positive to negative, from positive to negative, positive to negative. So the conventional of current inside, how it will be inside from negative to positive, inside from negative to positive it will be there. The conversion of direction of conversion of electric current. Conventional current is always opposite to the direction of flow of electrical charges ಅಂತ ಹೇಳ್ತಾರೆ. Conventional current is always opposite to the direction of flow of electric charge. Understood? So similarly here the pattern of magnetic field lines, I will rewrite this diagram. So how it will be? Last class our teacher, one of the teacher, he troubled. See, this is the north pole, this is the south pole. This side is covering, I think, I hope it is covering. Yes. See, it can, the sir has used 3 lines. I will use 3 lines only. You can write this side also. You can, the pattern of field lines like the same you can write, no problem. But the direction is very important. This is the bar magnet. Again they will go and join here. They will come and join here. For one I will write. Okay. See here the arrow mark is outwards, but here the arrow mark should be inwards. They should end or terminates at south pole. This is the pattern of magnetic field lines. The magnetic field is more at poles. At poles the field is more. Magnetic field is denoted by B. Magnetic field. Electric field is denoted by E. These are the similarities. Is more at poles. Why the field is more at pole means the field lines are more crowded near the poles. The magnetic field lines are more crowded near the poles, whereas less crowded near this is in the middle. In the middle of the bar magnet, less crowded. That's why the magnetic field is more at the poles, whereas less at the field is less in the middle of the bar magnet. In the middle exactly it is 0, but near to the center it is less. So this I hope some of the similarities I have discussed here between electrostatics and magnetostatics. In electrostatics, electric charges will come here. In magnetostatics, poles will come, north pole and south pole. Positive charge similar to north pole, negative charge similar to south pole. Like charges will repel, like poles also will repel. Unlike charges will attract, unlike poles will attract. Unlike poles means north south. So in electrostatics, we will study about electric field. Here we will study about magnetic field. Here we will study about EFL, electric field lines. Electrostatics we will study about, in electrostatics we will study about electric field lines. Here in magnetostatics we will study about MFL, magnetic field lines. Understood? Related to field lines also some similar properties are there. Field lines, even electric field lines will never intersect each other. Same like magnetic field lines will never intersect each other. Both electric field lines and magnetic field lines will never intersect each other. That is I will discuss later in the next class. Why they will not intersect. These are the similarities. Okay. Understood? This E and here B. Here electric field lines, here magnetic field lines. Like charges and like poles, unlike charges and unlike poles. Pattern of magnetic field lines, pattern of electric field lines. Electric dipole and bar magnet. Electric dipole and bar magnet. So now I will go to that Coulomb's law and Biot-Savart's law. After that similarities I will write. Here some more similarities are there, 2 more after deriving the Coulomb's law and Biot-Savart's law we will get some similarities. Here the constant, I will say now only, here the constant epsilon naught will come, here mu naught will come. mu naught. Permittivity and permeability. Epsilon r means permittivity. Permittivity means ability of the substance to allow the number of electric field lines. Same here, permeability. Ability of the substance or bar magnet or any device to allow the number of magnetic field lines. Permeability. I will write here permeability. I will erase all this and I will write here similarities and here similarities. Later that I will do that Coulomb's law and Biot's law. I will erase these diagrams and all. See, only I will keep this electrostatics and magnetostatics, Coulomb's law, and only this much I will keep. Coulomb's law and Biot's law. This also I will completely explain. Now you will understand. I will write here separately what and all the similarities will come here and here. So here first one is positive charge, negative charge. Here north pole, south pole. Next, it is related to electric field, it is related to magnetic field. Here we will study about EFL, electric field lines. Here we will study about magnetic field lines. We will deal here with electric dipole. Here we will deal with bar magnet. Here we will deal with bar magnet. Here the constant is epsilon naught. Similarly, here the constant is mu naught. Here 1 divided by 4 pi epsilon naught will come. 1 divided by 4 pi epsilon naught will come. Here mu naught divided by 4 pi will come. Mu naught divided by 4 pi will come. So what is this epsilon naught? Permittivity. Epsilon naught is permittivity. This is permeability. Today only one thing I am using. Permeability. What is this epsilon naught value? 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Mu naught value 4 pi into 10 to the power of minus 7 Henry per meter. Understood? These are the similarities. Substitute this value of 8.854 into 10 power minus 12 here. Here 1 divided by 4 pi epsilon naught is there once again. 1 divided by 4 pi epsilon naught, and simplify. Pi means 3.14 you can take, multiply with 4 and this value and take the reciprocal, because 1 divided by 4 pi epsilon naught is there. This actually K is equal to, in electrostatics we will denote that K is equal to 1 divided by 4 pi epsilon naught. After substituting all this value, it will come 9 into 10 to the power of plus 9. This Coulomb square per Newton per meter square will become reciprocal, because epsilon naught is there here in the denominator, 1 divided by 4 pi epsilon naught. This SI I will take reciprocal, then it will become Newton meter square per Coulomb square. Very important value, this one is Newton meter square per Coulomb square. Very important value, K value. Nine into 10 to the power plus 9 Newton meter square per Coulomb square. Very important value. Understood? Now I will go to 20 minutes over remain. 20 minutes are there. 40 minutes it will I will record. The ability, the YouTube that we need to upgrade. Only 40 minutes video it will receive. Now I will go to this Coulomb's law and Biot-Savart's law. So Coulomb's law, you can take two positive charges, you can take positive or negative, no problem. Depends upon the polarity, the force will be repulsive and the force will be attractive. Separated by distance, in generally R Q1 Q2 is there, therefore R12. What is the statement of Coulomb's law? The electrostatic force of attraction or repulsion. The electrostatic force of attraction or repulsion is directly proportional to the product of the magnitude of the two charges and inversely proportional to square of the distance between them. What is the distance between the two charges? R12. Let Q1 and Q2 be the two positive charges, 2 point charges you can say. Q and Q2 be the 2 point charges. R12 is the distance between those two charges. According to the statement, very simple. That's why I will not repeat more. Very simple. This hydrostat is completely based on Coulomb's law. This hydrostat is completely based on Biot-Savart's law or Laplace law. So now, according to the statement, F is directly proportional to Q1, Q2 divided by R12. First you can take directly proportional to the product of the magnitude of the charges, inversely proportional to 1 divided by square root of R12 square. Combine these two, F is directly proportional to Q1, Q2 divided by R12 square. To remove this proportionality constant, they will use K. So therefore, F is equal to K times of Q1, Q2 divided by R12 square. Understood? R12 square. Where this K value, just now I told what is K value. K is equal to 1 divided by 4 pi epsilon naught. Therefore, F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 square. This is Coulomb's law. It is having some drawbacks. What is the drawback? It is applicable only for stationary charges. Once if the charge moved, this law will become invalid. And this is not a universal law. Those are the two demerits, drawbacks, or disadvantages, or limitations also. Sometimes they will ask what are the limitations of Coulomb's law for 2 marks. For 2 marks question, they will ask limitations or drawbacks or disadvantages. The first one is, it is not a universal law. It is not a universal law, just like universal law of gravitation. It is applicable only for stationary charges. It is applicable only for stationary charges, not applicable for once if the charge moved, it will become invalid. So this is Coulomb's law. This is Coulomb's law. For 1 marks question, this maximum they will ask for 2 marks or 3 marks. Maximum this Coulomb's law, they will ask for 2 marks or 3 marks. State and explain Coulomb's law. State and explain Coulomb's law. For 1 marks, sometimes they will ask write Coulomb's law in vector form. Write Coulomb's law in vector form. Okay. So later I will write that equation because here this space I will utilize for Biot-Savart's law or Laplace law. The space will become a shortage. Now Biot-Savart's law. Magnetostatics completely depends upon the Biot-Savart's law or Laplace law. Magnetostatics completely depends upon the Laplace law or Biot-Savart's law. So you can take one current element. I will write diagram here because this space I need to utilize. One conductor. In that conductor, I will take one small element of length dl. Here I will consider the point P. From distance of that point P from the conductor is small letter r. Now at this point, what is the magnetic field? At this point P, what is the magnetic field? Circular coil derivation will come. There are an expression for magnetic field due to a circular coil along the axis of the coil. Very important derivation. Almost every year or 2 years once they have asked that question for 5 marks. Very lengthy derivation. ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ನಾನು ಲಾಸ್ಟ್ ಟೈಮ್ ಯೂಟ್ಯೂಬ್ ಕ್ಲಾಸ್ ಮಾಡಿದ್ದೆ ನಾನು. ಸೊ ಅಲ್ಲಿ ಇದೆ, ಆಲ್ರೆಡಿ ಅಪ್ಲೋಡ್ ಆಗಿದೆ. ದಟ್ಸ್ ವೈ ಐ ವಿಲ್ ನಾಟ್ ಡೂ ದಟ್ ಡೆರಿವೇಷನ್. ಇದೇನು ಮಾಡಿರಲಿಲ್ಲ, ಇದನ್ನು ನಾನು ಯಾವುದು ಮಾಡಿಲ್ವೋ ಅದನ್ನು ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ಆಲ್ಮೋಸ್ಟ್ ನಾನು ಯೂಟ್ಯೂಬ್ ಕ್ಲಾಸ್ನ ಈ ಸ್ಯಾಟರ್ಡೆ ಸಂಡೇ ಏನು ಮಾಡ್ತೀನೋ ಕಂಪ್ಲೀಟಾಗಿ ಕವರ್ ಮಾಡ್ತೀನಿ. ನಾನು ಕಂಪ್ಲೀಟಾಗಿ ಫಿಸಿಕ್ಸ್ 12th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಿಸಿಕ್ಸ್ ಕಂಪ್ಲೀಟಾಗಿ ಕವರ್ ಮಾಡಿ ದೆನ್ ಐ ವಿಲ್ ಗೋ ಟು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. ಮ್ಯಾಥ್ಸು ಕೂಡ ಮಾಡಬೇಕು ಅಂತ ಇದ್ದೀನಿ ನಾನು. Even this 12th May, first I will do 12th CBSE or PU mathematics. Physics maths main ಆಗಿ ನಾನು ಏನಾದರೂ ಸಾಧನೆ ಮಾಡಬೇಕು, ಗ್ರಿಪ್ ತಗೊಳ್ಬೇಕು, ಬೋತ್ ಫಿಸಿಕ್ಸ್ ಮ್ಯಾಥ್ಸ್ ಅಂತ ಇದ್ದೀನಿ. ಆಫ್ಟರ್ ದಟ್ ಐ ವಿಲ್ ಕಮ್ ಟು 11th ಸ್ಟ್ಯಾಂಡರ್ಡ್ syllabus. See, like this, here Coulomb's law. What is that? The electrostatic force of attraction or repulsion is directly proportional to the product of the magnitude of the charges and inversely proportional to square of the distance between those two charges. Here also the magnetic field dB, the statement, what is the statement? The magnetic field dB means small magnetic field, B means larger. After differentiation, integration of dB, what? B will come. Integration of dx, what will come? Only x will come. Understood? Like that. The magnetic field at a point P is directly proportional to the, here current ಇಲ್ಲ ಹೆಂಗಪ್ಪ, ಆಮೇಲೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರಬೇಕು ಕಂಡಕ್ಟರಲ್ಲಿ. ಕನ್ಸಿಡರ್ ಎ ಕಂಡಕ್ಟರ್ ಕ್ಯಾರಿಂಗ್ ಕರೆಂಟ್ ಐ. ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಬೌಟ್ ದ ಡಯಾಗ್ರಾಮ್ ವಿತಿನ್ 2 lines. Consider a conductor carrying current I. Let P be a point at a distance small letter r from the midpoint of the conductor. P be a point at a distance small letter r from the midpoint of the conductor. dl is the small elemental length of the conductor. Now the magnetic field, small amount of magnetic field dB at a point P is directly proportional to the current flowing to the conductor, and that dB is directly proportional to the small element of the conductor, and that dB is directly proportional to sine of the angle between the conductor. Theta ellirutte illirutte. Sine of the angle between the conductor and the line joining the point P and the conductor. Understood? This is the line joining point P and the conductor. This line, the joined line, creates an angle theta with the conductor. That for that sine of the angle of theta, this magnetic field is directly proportional. dB is directly proportional to sine of the angle between the small elemental length of the conductor and the line joining the point P and the conductor, and inversely proportional to understood, dB, that dB is inversely proportional to square of the distance between idu, here square of the distance between the 2 point charges, but here square of the distance between the point P and the conductor. Combine all these equations and write it as a single. dB is equal to, ಇದು ಕವರ್ ಆಗ್ತಾ ಏನಪ್ಪ, ಕವರ್ ಆಗ್ತಿದೆ. So dB is directly proportional to IDL sin theta divided by r square. In Coulomb's law, we have used the constant to remove this proportionality constant, to remove this proportionality term. 1/4 epsilon naught we have used, but here we will use mu naught divided by 4 where mu naught is permeability of free space. Therefore this equation will become, Biot-Savart's law equation will become dB is equal to, remove the proportionality constant, mu naught divided by 4 this is the constant, and IDL, not ideal, IDL, I into DL, not this IDL, I into DL into sin theta divided by r square. This is the Biot-Savart's law or Laplace law. Two names are there. Understood? Electrostatics completely depends upon the basic main building block of electrostatics is Coulomb's law. Similarly, the building block of magnetostatics is Laplace law or Biot-Savart's law. Other will come Gauss law here and there, Ampere circuit law. In electrostatic, Gauss law will come here, Ampere circuit law will come. Electrostatics will deal with electric field lines. Here we will deal with magnetic field and magnetic field lines. So now I will write the vector form of that Coulomb's law and vector form of Biot-Savart's law. Both are there. For 1 marks question they will ask. Just we need to write the equation bariyaste. Only just write the vector form of equation. For 1 marks they will ask one equation you have to write. After that I will discuss some properties of bar magnet and I will end up this class today. So I will erase this. ಒಂದು ಫೋಟೋ ತಕ್ಕೊಳ್ಬೇಕಾಯಿತು ಬಟ್ ಮೊಬೈಲ್ ಅದು ವಿಡಿಯೋ ಇದಾಗುತ್ತೆ ವೆಯ್ಟ್. Okay, next vector form of write an equation. Just write the vector form of Coulomb's law. So I will completely erase this. Vector form of, for 1 marks question they will ask, write the vector form of Coulomb's law or vector form of Biot-Savart's law. Coulomb's law vector form, for 1 marks question they will ask F12 is equal to 1 divided by 4 pi epsilon naught Q1 into Q2 divided by R12 square. Again here you can put R cap, where R cap is here 12 will come, here 21 will come. Like this you can write. This is the vector form of Coulomb's law. This cap K means vector. Mathematics we know. Here 2-1 you can use. Both are possible. 2-1. That is, this is also possible. 1 divided by 4 pi epsilon naught. This will be same. Q1 Q2 divided by R12 square. Cross will come. Q1 cross. Here 2-1 came, here you can write 1-2. Cap you can put like this. These two equations, anyone you can write, no problem, they will give marks. Or 2-1 or 1-2 you can leave, just in general form you can write F is equal to 1 divided by 4 pi epsilon naught, right here. This is because force is a vector. So Q1 cross Q2 divided by R square into R cap. This also possible you can write down. General form 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square into R cap. General form. Out of the three equations, anyone you can write, they will give marks, no problem, out of the three equations. Next, similarly, Biot-Savart's law vector form. So dB is equal to, field is a vector field. Last class our maths sir while doing, the name itself vector field. Field is a vector having both magnitude and direction. Vector field ಮಾಡಬೇಕಾದ್ರೆ bar magneto he tried to write the magnetic field lines. dB is equal to mu naught divided by 4 phi, mu naught divided by 4 phi ideal sin theta divided by r square. I cross dl divided by r square into r cap. This is the vector form of magnetic field lines. Sin theta, I have removed that sin theta, ideal sin theta. This cross product in mathematics, a cross b is equal to ab sin theta. The cross product will get removed after using sin theta. That's why I have removed sin theta and used cross product, ideal divided by r square into r cap. This is the vector form of Biot-Savart's law. 5 minutes more, I will just discuss the properties of this magnetic bar magnet. First property. How to identify this bar magnet north and south poles? You can take any magnet or a solenoid, current carrying solenoid. You can hang that in a free space or laboratory. You can hang one bar magnet. So it will oscillate, and it will comes to rest. It will oscillate, and it will comes to rest and stands along the direction of north and south of geometric earth. It will oscillate, and finally it will stand along the geometric north and south of earth. Even earth is also one of the bar magnet. North and south. It will oscillate, vibrate, and it will come and stand align in this direction. And at the time, how we will identify the poles? The pole which is directed towards the geometric south of the earth. Earth is also one of the magnet. North and south. The pole which is come and stand, it will come to rest, align in this direction. The pole which is pointing or directing towards the geometric north of earth is called north pole, and the pole which is directing towards the geometric south of earth, that is called as south pole. Like this we will identify the north and south poles of the bar magnet. How to identify? Hang the bar magnets in a laboratory in a free space. Hang means you can suspend using a stand, not hang means either fanning name. So you can hang them, suspend vertically in a direction like this. Then the bar magnet will oscillate, and it will come to rest and align in this direction, geometric north and south of the earth. Then the pole which is directing towards the geometric north of the earth is called a north pole, whereas the south which is pointing or directing towards the geometric south of the earth is called south pole. Like this you can identify the poles. Next, this is the first property. Second property, like poles will repel, whereas unlike poles will repel, unlike poles will attract. Like poles means north, south will repel. Unlike means north and south will attract. Attract positive and negative charge. Understood? That is the second property. Third property is very important. This is the third property. You can break this bar magnet into number of pieces. You can break this bar magnet into cut them into n number of pieces. You can like these small pieces. Understood? All the pieces will be having north, south. That means monopoles will never exist ಅಂತ ಹೇಳ್ತಾರೆ. Monopoles will never exist. You can break them and cut into n number of pieces. Each and every pieces will acquire two poles, that is north and south pole. Monopoles will never exist. You can cut them into n number of any pieces, 100,000 you can cut. For each and every pole there will be a north and south pole. I mean monopoles will never exist. That is the property. That is the third property. Fourth one, this bar magnet made up of ferromagnetic materials. What are the ferromagnetic materials? It will comes in chemistry also. Ferromagnetic materials. Ferromagnetic materials like iron, nickel, cobalt. Iron, nickel. Spelling is very important. Okay. Spelling is very important. Iron, nickel, cobalt. ನಿಕ್ಕಲ್ ಕೋಬಾಲ್ಟ್ ಈ ಥರ ಅವಾಗ ಜೋಕ್ಸ್ ಮಾಡೋದಕ್ಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ತುಂಬ ಇಷ್ಟಪಡೋರು ನನಗೆ. ಕೆಲವೊಂದು ವಿಷಯಗಳು ಜೋಕ್ಸ್ ಮಾಡಿಬಿಡ್ತಾ ಇದೆ, ಬೋರ್ ಆಗ್ತಾ ಇರ್ತದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಕೇಳಿ. ಐರನ್, ನಿಕ್ಕಲ್ ಆ್ಯಂಡ್ ಕೋಬಾಲ್ಟ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? Once again I will repeat what are the properties. First one, how to identify the north and south poles. Hang them, suspend freely in a open space or laboratory like this using a stand. The bar magnet vibrates, oscillates, and it comes to rest along the geometric north and south pole of the earth. ಸ್ವಲ್ಪ ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾನೆ, 40 minutes ಎಕ್ಸಿಟ್ ಆಗಿದೆ. Then the bar magnet will come and stand in a direction like this in the geometric north and south pole of the earth. Now the pole which is pointing or directing towards the geometric north of the earth is called the north pole. Similarly the pole which is directing or pointing toward the geometric south of the earth is called south pole. Second property, like poles will, the like poles will repel, north, south, whereas unlike poles will attract. Third one is, what is the third property? You can cut or break the bar magnet into n number of pieces, then each and every piece should acquire two poles, north and south. That means monopoles, unipoles, monopole bar magnet will never exist. That is the third. Fourth one is, bar magnet is made up of ferromagnetic materials like ಐರನ್, ನಿಕ್ಕಲ್ ಆ್ಯಂಡ್ ಕೋಬಾಲ್ಟ್. ಸೊ ಇವತ್ತು ತುಂಬ ಖುಷಿ ಆಗ್ತಾ ಇದೆ, ಒಂದು ಕ್ಲಾಸ್ ಮಾಡಿದ್ದೀನಿ ಅಂತ ತುಂಬ ಖುಷಿ ಆಗ್ತಾ ಇದೆ ನನಗೆ ಆ್ಯಕ್ಚುಲಿ. ಸೊ ಐ ವಿಲ್ ಎಂಡ್ ಆಫ್ ದಿಸ್ ಕ್ಲಾಸ್. ಥ್ಯಾಂಕ್ ಯು, ಬಾಯ್.